Well, good morning, everyone. It's really exciting to be here. Just a short introduction about myself. My name is Ismail Habib Muhammad. I'm a software engineering working for Mendix. That's a company in the Netherlands. And just like any other technology company, we're always hiring. So if you're looking for something, just talk to me afterwards. I'm going to talk about the actor model on the JavaScript environment and the library that we built on that basis, which is called Actrix. So just like what Michel Westraat said yesterday in the main stage, it's nice to be able to give ideas and trying to inspire other people with my talk. So it's not necessarily about promotion of the library itself, but it's about inspire others. But that would pretty much depend on whether I can stop my knee from shaking the next 15 minutes. So let's go. Oh, that's a bit unfortunate, but what it says there, it's asynchronous process is hard. So I'm coming from Java background, and well, especially there when I was working, there's not much asynchronous API. You basically see mostly synchronous things, and when I start doing things in JavaScript or in TypeScript, then you cannot really hide from doing things in asynchronous way. And it's not just hard to write, but also especially it's difficult to reason about. Like sometimes you just don't know anymore what's happening there because well the flow of control is not visible on the code. You can't see it there. This is probably also why well we in JavaScript you start with this callback and you have a callback hell, and then there are promised things start to improve a bit. And then eventually async await, which is like quite a good situation, but it doesn't cover everything yet. There are still some challenge that we have when we're writing asynchronous code behavior in JavaScript. This is an example of a chat room. Here I'm creating a mock function. I call it connect. So basically. When you want to have your code to connect to a chat room server. This is basically just a code that will resolve somewhere between 0 milliseconds to 2000 milliseconds, so nothing special here. And here is the implementation. I call it just a naive chat user, where you have a listener here. Don't pay too much attention to it. This is just a binding to the UI. You can use whatever UI you want to use. And there is a method that is called subscribe to room, which will trigger the asynchronous call to the connect function that I showed earlier, and afterwards triggering the callback listener and sending a message that you are connected to room something. And here's another short code which is pretty obvious. So first part is when you instantiate the object of the naive chat user with a callback that you want to provide. And also the part where you're subscribing to a specific room that you trigger from an event, like clicking or switching or whatever. And this is a bit of a demo to show what kind of problem we have with that code when trying to do asynchronous call when switching from one room to another room. So here, you see there's a radio button, basically 3 options, room 1, 2, 3, so you're trying to connect to one of the room. And when you click to one room and then you get connected, it will print a message to the screen. But as you can see, once I start to click like crazy, switching between rooms, at the end, you see that a message that you are connected to room number 1, but my radio button actually in the room number 2. This is because of the situation with asynchronous call. You'll never know which call that you trigger will be coming in what kind of order. So you don't know, you don't have much control over that. There is a simple solution for this by just adding, sorry, adding an ID. And then you keep that ID, you keep incrementing it whenever the subscribe to room method is being triggered. And then at the end of the asynchronous call, you check it, see if that's the same ID as you start in the beginning. And if it's the case, then you can continue with triggering the callback. But otherwise, just yeah, skip it, and then because you know that it's not the latest callback that you actually trigger from the user interface. Here's a bit of a demo of that solution. Now you see there is much less message because a lot of messages are being ignored because the ID is no longer equal to the latest one that you trigger. So it kind of works, right? It works like we expected. But I would argue that this is not the best solution. One, you have to put a check every time you make an asynchronous call to actually see if it's still the continuation of the latest call that you're making. Imagine if you have much more complex code, more asynchronous call there, then you have to put it everywhere. And also, it's still a bit difficult to process in your head, because every time you work on this method, you have to think about that situation again, or you do something different, like blocking the UI, but that's a completely different discussion, I think. So before we are talking about how we solve this in a better way, I would like to talk a little bit about the actor model itself. So what is an actor model? So an actor model is a model that treats actors as the universal primitives of concurrent computation. It's quite a mouthful. It's not really necessary to understand the entire thing, but this is something that you also see in other environments like Smalltalk, in JVM with Akka, or in Erlang. And what is actor itself? So actor is like an object. It's a bit similar to an object. It's a building block for application. So you can build your application based on actors. But instead of invoking something inside it, like what you usually do with an object, you're sending message to it. And this message is being sent in a synchronous way. And actor handles those messages in a sequential fashion. So it never does two things at the same time. But the message that is being sent to an actor will actually be queued in something that sometimes we call the mailbox. And then the actor can process that sequentially according to what it wishes. And an actor also keeps local states. So it doesn't share its states or even allow other actors to mutate its states directly. They have to use the messaging mechanism to be able to influence one to another. And actor lives inside an actor system. So, historically, why do we use actor model? Like in the multi-threaded environment, initially there is a need to solve a concurrency problem. And the traditional solution with thread based in the multi-threaded environments, they're using lock. So basically, whenever a code needs to reach a certain value that is being shared by multiple threads, then one of the process will lock access to that variables and causing the other process to wait until that's done. This is causing a lot of problems. One of them is the resources, because threads are not cheap, so there's a limited amount of threads you can have in the system. You can get into a deadlock situation because one process block another and the other block another, and then you create a circular waiting. And it also results in horrible code, which is also really hard to follow and to maintain. What about actor model in JavaScript? Like, what's the state of actor model in JavaScript? Well, I tried to look around a bit, but most of the implementation, they are not very much adopted, so there are some adoption, but not that much. And they are very much designed for the Node.js environment only. But the asynchronous problem is not some problem that we only have in Node.js, but also in the browser. This is why we decided to build a library called Actrix. So this library is available as an open source project. You can check it later. I would not suggest you to use it in production yet, because it's still pretty much in very early stage. Although in Mendix we are using them, so but we build it, so it's up to us. The chat room example again, but now we are trying to implement it in Actrix. As you can see in the code, there is not much difference between this code and the code that I saw earlier with the naive implementation of asynchronous process. The things that differ here is that the implementation extends an actor, but the subscribe to room implementation here is exactly the same as we see in the previous one. And well, let's see what happened. Well, there is other synthetic things, like how you create an actor. You create an actor system first, and then you create an actor, giving it a template, which is basically just a class name, giving some parameter options where we pass the callback to the actor so that the UI can update itself accordingly. And the most interesting part is how you trigger or actually sending message to an actor. So you're either you're sending a message in a fire and forget fashion, so you send it and then you don't care what happened with it later, or you're actually asking something to an actor where you actually want to await and you're interested in seeing if there is any response from that actor. This difference might be subtle, but depending on the use case, it's important to think about it. So a bit of a demo of that implementation. Still the same examples, chat room examples. You see here, I'm switching between the room, and in the end, it connected to the room too, as we see in the UI as well. But well, you must have noticed something else here as well. Like in the end, you are in the right state, you're in the correct room, but at the same time, it doesn't give you a good feedback. This is due to the sequential processing, that every process takes a certain amount of time. We implement that in something between 0 to 2,000 milliseconds. And then when you actually make multiple calls rapidly, then you're filling the mailbox. And since actor process the mailbox one by one, there is some kind of delay on your user interface. So sequential process, it's really nice. It solves the problem of the difficulties of trying to reason your code. But on the other hand, the user experience is it's not the best. So, well, it's not the end of the world. So we can still look into what is possible in the actor. I was actually expecting some kind of reaction here because there's a wrong memo. This should be the one. So we need to try to optimize the things. What is possible with this approach? What can we do better? So one of the most obvious ways is to do short-circuiting. So in the method itself, the subscribe to room method that we saw earlier, we can easily just check by picking into the mailbox to see if there are more messages there with the same type. In this case, the subscribe to room. And if there are messages there with the same time, you probably don't want to continue with executing the current message that you're handling now, because you know that it will be outdated anyway. But what happens if we already actually running the process, and the process is not just like 2 seconds, but it can be much longer. So we probably need some kind of cancellation strategy. And in Actrix, cancellation is possible because we have a handler for every time there is a new message coming into the actor. And this is called the onNew message. You can pick into the mailbox. You can see what type of message there are. And you can also decide to trigger the function that is provided in the Actrix actor, which is called the cancel for current execution. But how is this possible? I mean, there is no cancellation in Promise, or at least there is a lot of conversation about it, but nothing really materialized. But in Actrix, we provide a function to turn generators into a cancelable promise. So this is exactly the same as normal promise, but with a cancel feature. The only difference here is that instead of using async syntax, we're using star, which is something that you use to create a generator. and instead of using await, you're using yield, and then everything else are exactly the same as the code that we saw earlier. To put them all together, is like how it looks like. The chat user actor implements an actor. It has a init method where you set the callback to the UI. You have the on new message handler to handle a new incoming message in case that you want to cancel current execution. And you also have this slightly altered subscribe to room method. So a demo. Again, same demo with the optimized actor solution. And you see here, whenever you're switching rapidly, you don't actually continue with the execution, but you just go to the next one because you're either canceling the currently running process or you're short-circuiting the code itself. So, well, it's nice. Can we do better? Of course, because it's very generic solution, and we can simply just bake it into the actor itself. Something that I called a strategy. So basically, if you decide that you want to have this strategy to ignore older message with the same type, then you don't have to put in all the extra boilerplate from before, and instead, this is the entire code that you will need to have. You still need to have the cancelable promise implemented in generator, but the on new message handler is no longer necessary here. So then I'm saying, like at the end, it's possible to try to generally solve the sequence problem because actor model itself, the approach itself, it gives a better control over flow execution. So instead of doing things like the way object does, actor have a better control because they are actually executing things in asynchronous function, and they are keeping the queue on their own hand, so they can decide they can do interesting things with it, like what I've shown earlier. Okay, well, that's kind of example, but we haven't really implemented the chat itself. It's just a method to try to connect to a mock function. But let's go and try to implement the rest. So I tried to implement it by first making a design diagram. Here you see a user actor, and then there are more user actors, which it probably resides on different browsers. And then you have room actor. Since we have 3 rooms, then I call them room actor 1, 2, and 3. Here you have arrows connecting between the actors, and also something there which is not really visible, but basically it says post and subscribe to. Those are the type of message that you want to use to bind the actor with the non-actor word, which is in this case a UI itself. From an actor to a room, you can subscribe, you can unsubscribe, and you can also post a message. And room can send a new message whenever there is a new one coming. And yeah, but that seems to be very simplistic because those actors are located in different place. The user actor will resides in browsers, but the room actors, they are typically on the Node.js environment on the server side. Well, that generally makes things a bit harder because then you have to start building all those piping between the client and the server, all this code that you have to implement. But it doesn't have to be that way with actor model, because actor model can make it simpler. Well, the same picture as before. So basically what happened here, the user actor resides in the browser, which has an actor system in the browser, and the room actors, they have actor system on the Node.js. What if we can just like merge them together? Instead of making the complexity resides on the communication, we can just abstract that away by connecting to actor system together, and the actors themselves, the implementation of actors themselves, they don't need to know exactly where an actor actually resides. So the communication between actors can be done as if they're in the same machine. So this is a code to bind two actor systems together using socket.io. This is just an example of implementation. I have an idea to actually try to implement this in many other ways, like using HTTP or other things, but this is just a simple example. And the implementation of the user actors. We have the subscribe function, which is the same as before. We have, there are some extension here because we also want to unsubscribe to the previous room if the user has already subscribed to another room before. We can also post a new message, which is a very straightforward call to the room actor with the message that we have. And there's also a handler whenever you receive a new message from the room actor. This implementation for the room actor, you have a subscribe method. Whenever a user actor tries to subscribe for a message, you have unsubscribe as well. And also, when you want to post something, then it will go through the all list of subscription and broadcast that message again. This code is, well, it's not important to follow all of them right now. I already have some repository which shows the examples on how this can be used. Not exactly the same as this one, but pretty similar. So a little bit of demo on that one. You see two browsers here. So they are really two browsers. I didn't cheat. The first one immediately connect to the room tree and then say something, but because the other browser hasn't been connected yet, you don't see anything. But once they are connected together and they start sending message, the update can happen on both browsers immediately. So it's pretty simple implementation for a chat room, which well, it's not that hard to do once you follow the entire concept of actor model. And these things are possible because the message passing mechanism, the asynchronous messaging, it enables uniform communication patterns for intra and inter-actor system communication. So it doesn't really matter whether the actor that you need to reach actually resides within the same actor system or in different actor system. You can talk to them as if they are the same thing. And it hides, the complexities are kind of hidden away by the implementation of actor model, Actrix here. Well, that are some patterns, but are there more? Yeah, probably more. There are a lot of things that you can do with actor model. You can create a fault tolerance system with a supervisor strategy. There are also ideas of doing actors in clusters, so you have multiple backends instantiated, and you can talk to each other without actually needing to know where they are. And there are also a possibility to make delivery or order guarantee a bit more on the generic level when you're talking about distributed actor system. That's all. Well, that's all my presentation. Thank you for listening. Hopefully, it inspires some of you.
Yeah, actually that's a great example of trying to apply some of these patterns from one language to another. Mm-hmm. Probably the risk of doing this is that maybe you don't know some of the patterns that we use in JavaScript.
That's true.
That can do similar things. Mm-hmm. But you know, it's all a learning experience.
Yeah.
Okay, so we have some questions, and probably pointing to what I was saying, let's take the first one. So, have you got any experience with RxJS?
I did a few things with RxJava and look a little bit into RxJS. So I don't have like a very extensive experience with RxJS, but it still have some differences. Like you can use RxJS for a few things. First, you have to change your way of doing things with RxJS because it's basically like functional reactive programming, and it's completely different from if you're coming from the imperative way of doing things. So I don't want to push that to people who prefer to do things in the imperative way. And secondly, I think even with RxJS, you can still have some problems. So some problems can be fixed with RxJS, things like it has debound, so for example, it can prevent you from actually triggering things in a rapid fashion in a short time, but it doesn't really give you control over the sequentiality of execution. At least that's what I understand.
Sure. Okay, so let's see what other questions we have. I think we have enough time. We are going into the break just next. But here we have, how do you test these type of applications?
Mm-hmm. This is a very good question. So I don't have a very clear idea yet on how to do that. We do have some implementation of actor tests on our system, because you can never make your system running in production without testing them. But it's still kind of case-per-case basis, and that's one of the things that I would like to improve in Actrix, to actually provide some kind of framework to make it easy for everyone to be able to test the actor that they implemented. So, very good questions. I don't have the answer right now.
Okay, maybe we take the last one. Let's see. Can the same kind of functionality be done with Redux Saga? Are you familiar with Redux
I've heard
Saga?
about it, not very familiar with Redux Saga. I think the similarities is that they're both use generator. But, well, that's it. I don't know much about it, so I can't really answer that question.
Okay,
Sorry.
that's fine. That's fine. So if you have more questions, you can reach him on the breaks or maybe later today. But thanks a lot again for your
Thank you.
talk. Very interesting.